Now, how do I find the probability of a microstate? Sorry, of a macrostate? So the probability of the system to be in a particular macrostate can just be found by adding up all the probabilities for all the microstates. So a probability of finding the system in a particular macrostate. So a probability of the system to be in a particular macrostate is just given by adding up all the probabilities for all the microstates it contains, or fundamentally mathematically just given by sum over minus E over KT, where Z is just the partition function. And remember, the sum is taken over every microstate contained in the macrostate. In other words, we can also write this as PE is just going to be multiplicity E to the minus E over KT divided by Z. Now, since this is a very complicated way of thinking about it, may I reuse some of the math that I knew of beforehand to make this expression a little bit simpler? Okay, so let me explain that. So we know entropy is K log of multiplicity, which means I can rewrite this as S over K equals log of this, or E to the power S over K equals multiplicity. If I plug this value in the above equation, may I rewrite this flower equation as PE equals 1 over Z E to the minus E minus TS divided by KT. And that's the expression that you should probably remember. Now, this seems all very complicated, but let's do an example that will make it make more sense.